So the final, last but not least, presentation is by Olivier from the National Library of Medicine, and he will present from here, from Bloomington, Indiana. And Leonard is setting him up kindly. Thank you.
No, this one here.
Yeah, that's the one.
This one?
Yeah.
Okay. And you can use the clicker, and I'll give you the mouse as well.
Sure.
That's your verification.
Very good. Thank you very much. Good morning, everyone. Thanks to Kathy for inviting me, and thanks for crafting the program very carefully. Not only did you manage to have the two Jonathans follow each other, but you also managed to have Olivier follow Oliver. So that's very hard. Okay, so I should be able to go through this quickly. So that the title is Anatomical Ontologies, and how many of them do we need? There's some irony here, not to say cynicism, but we've alluded to a lot of these things this morning, so I should be able to work for this very quickly, and I will maybe just point a few elements. So this, I'm starting with a map. That's a map of sorts, I guess, that was drawn, that was bought from Barry Smith a number of years ago, in which they show different levels of granularity for what needs to be represented in general, not just for anatomy, but in general, and what kind of ontological types of entities we have to represent these kind of things. So I don't want to go into too much detail, but just to mention that anatomy was on the map at that time already, and they had identified a few important ontologies already existing at the time. For gross anatomy, there was the FMA, the Foundation of Modern Anatomy. We've talked about it. For cellular and subcellular anatomy, they had identified the cellular components of the gene ontology, and you alluded to that this morning also. And of course, if you go at the molecular level, we need to rely on different anatomies. So there are a few others that we've talked about, but this is what they had identified as part of the OBO family of ontologies. And I will mention a few others because I think they're important as well. So I had the FMA. Oh, I'm switching from 3 to 8, so maybe I need to go to the presentation because I'm missing the FMA. For some reason, I'm missing the FMA slides. Sorry. I'm not sure what's happening here. Yeah, so if you point to 4, actually. And yeah, and I can use I won't use the presentation notes for this. I will work in later. So I can try it. No, I'm not going to use.
You don't use it.
Yeah. Okay. So the FMA has existed for a long time. It was actually founded. The origin of the FMA is into the University of Washington digital anatomist, and that was an ontology of anatomy that was created for annotation purposes to annotate the visible human images, if you wish, because NLM had founded the digital human. It was over 20 years ago, and so people were already doing segmentation of the images, but there was no ontology that could be used that was precise enough to actually identify what was segmented, and that's how the digital anatomist came into being, and later became the Foundation of Modern Anatomy. So it's developed at the University of Washington. It kept growing and being better organized over time, to the point that it now encompasses over 100,000 anatomical entities. That's impressive. What I want to point out is that they make a distinction between subclass and between subclass hierarchies and part of hierarchies. And this is important. They don't mix the two, whereas many other terminologies or ontologies tend to mix both. So for reasoning purposes in particular, it's really important to have them separate. And you may not find this in Uberon or in other terminologies. So that's an important distinction. They also use OWL for the representation. They started using other things, but they now have an OWL distribution. And that's to show you a little bit what it looks like. So you have this top level that's already very carefully designed, an anatomical entity is divided into these concepts are not too meaningful, if you wish, but they are very important when it comes to structuring the bottom concepts. So they separate anatomical entity into physical versus non-physical anatomical entities. And the physical anatomical entities are material or immaterial. The material ones are the organs and the kind of things that you would expect. And the immaterial ones are the spaces, the boundaries. And so the kind of stuff that we need to be able to talk about, so it needs to be represented, even though it doesn't necessarily have a practical implication for annotation purposes, but it needs to be represented very carefully in order to just distinguish between various kinds of entities. No time to go into the details. By the way, this is a browser that was developed for the FMA by Melissa Clarkson. We talked about her last night. And I'm not entirely sure it's still functional, but it's a beautiful browser that helps you navigate following the various types of relations and the various aspects of the concepts. And so you're not surprised to find identifiers and the text definitions for the various anatomical entities. What's important is that there's also anatomical knowledge built in it. For example, what's the vascularization, what's the supply for a given organ, and also types of relations that you don't necessarily that go way beyond design product, but adjacency relations, containment relations that are really important when it comes to doing reasoning, not just annotation, but also reasoning with these elements. And the FMA was used in another project that has some similarities to what you're doing, which was the Visible Human Soldier that was funded by DARPA. It was about 15 years ago. And the anatomical knowledge was supplied by the FMA. And the idea was, well, if a soldier gets a bullet at some point in the body, are they going to die? Are they going to be? Do they need to be transported urgently to the next medical facility? And it was great to see ontology in action, if you wish, not just creating these hierarchical structures, but seeing them being used to serve use cases. I think I can resume with the presentation right there. Okay.
Yeah, you can use Twitter.
And so, switching levels of granularities, we're talking about gross anatomy mostly for the FMA. Now, if you go to a finer grained level of resolution, there's the cellular component hierarchy of the gene ontology, 4,200 classes. What's important also is that the gene ontology is a very stable ontology. It's been there for 20 years. It's developed by the Go Consortium. They've enjoyed consistent funding over these 20 years. And that's really important so I understand that you're not so much into creating a new ontology of anatomy. My first reaction when I heard about this project and ontology of anatomy was, oh, I hope they're not creating another one. But so I understand that you're borrowing from others, but it's also important to see what kind of maturity and stability the ontologies you want to borrow from have, because you don't want to take something that might disappear in a few years or no longer be maintained. SNOMED, we mentioned SNOMED in a couple of times this morning, and it is important in the sense that SNOMED is the largest clinical terminology in the world. They have 39,000 academical concepts. It's somewhat similar to the FMA, not strictly, but it's somewhat similar in the sense that SNOMED has been developed for its anatomy components, more or less in collaboration or in close discussions with the FMA developers. So the representation of anatomy in SNOMED is different for historical reasons, and I don't have time to go into this. But in spirit, the two are fairly aligned, with one major difference. It is that the FMA represents canonical anatomy, and we talked about canonical this morning, and how it's difficult sometimes to encompass the level of variation that we see in actual values under a canonical representation. But the FMA developers carefully carved this canonical representation, and they excluded, because they didn't have funding to represent this, they excluded surgical anatomy, they excluded abnormalities, and these things need to be represented in clinical terminology, and that's the reason why SNOMED goes beyond what's in the FMA to also represent, how do we describe anatomy after part of the organ has been removed or in abnormal circumstances. It's important to pay attention to SNOMED also because SNOMED is what you're going to find represented in electronic health records. It's developed by a consortium of 40 countries, so it's also extremely stable at this point. It's been around, the current version SNOMED CP has been around for 10 years or more at this point, and this consortium has grown from 7 countries in 2017 to 40 now, which means that there's broad adoption around the world. And if you need to relate to, or if you want to relate to existing patients and relate to electronic health records, you will need something like SNOMED to be able to reach into these electronic health records. And so even if you have FMA identifiers, for example, it's going to be extremely useful to have cross-references to SNOMED just for the purpose of being able to link to human medicine and electronic health records. We talked about Oberon, and I mentioned it here because that's what you need when you want to go across species. And I'm just going to mention it here. And of course, there are many others. If you want to link to the biomedical literature, you're going to need to rely on the anatomy in mesh, for example, and this is just an example of the A tree. That's called the A tree in mesh. That's the first of all trees in mesh, and it has some representation of anatomy. So mesh is not necessarily the example that you need to follow in terms of representation, because it's being developed for a very specific purpose, which is indexing the biomedical literature and retrieving the literature. So it doesn't mean at all that the organization that they use has any ontological foundation, if you wish. It just means that the hierarchies that they create are helpful for the purpose of indexing and retrieving. The NCI thesaurus was mentioned this morning. There's a nice representation of anatomy, and there was actually a nice representation of anatomy in the Galen project. That was a project that's almost contemporary of the UMLS, that was developed in Europe by Alan Rector and his team in the early 1990s, and they created a description logic representation of biomedicine, including anatomy. And of course, for specific species, there are specific ontologies, and only a few of them are mentioned here. So there's a lot there already, and so do we need one more? And so I know it's not necessarily your intent, but my answer is going to be definitely not. So if you don't want to create one, you may want to select one among the existing ones. And of course, depending on your use case, the use case has to come first. And depending on your use case, you may want to find something that targets human anatomy versus the anatomy in other organisms, or maybe both. And if you need to go across, there's going to be Uberon, for example, to help you with this. I would urge you to not forget clinical. And so the research ontologies are good, and I'm all for the oval-foundry ontologies, but at the same time, none of the oval-foundries ontologies are used for clinical medicine, are used in clinical electronic health records. And if you need to reach your electronic health records, you will need to deal with the clinical ontologies, for example, SNOMED. So don't drill this into your use case if it's something that you want to do at the end, because you don't want to end up mapping in hasty ways at the last minute. We already talked about levels of granularity, and then there's the housekeeping or the mundane aspects, if you wish. Who maintains the thing that you use? It's different if it's a group that has stable funding versus a grad student who might have developed the best thing at the time, but you know it's not going to be maintained. Are there regular updates? Do they use proper versioning methods? Are there any interproperty restrictions? And do you need to pay attention to this? And are they already creating? Are they already developing cross-references? Otherwise, you may be left having to do that yourself. If you use more than one, you will need to integrate. And that, I'm not saying too much about this because Jonathan already showed you how the UMLS helps you do this. Go across FMA, MESH, SNOMED, and the Go cellular locations that are the four major ontologies of anatomy that are already integrated in the UMLS. At the same time, navigation, the hierarchies are as important as the synonymy relations, because maybe what you're looking for is not a synonym in this concept that you're pointing to, but you can reach from this to a higher level of granularity or a lower level of granularity. So it's always a matter of pointing to something and then being able to navigate from there to other terminologies. So maybe the term that you want to map to doesn't exist in the other ontology at the very level of granularity, but you can map to something that's slightly higher, and it might still be good enough for your use case. Of course, a lexical similarity, which is a lot of what drives synonymy in UMLS, not the only thing, but a lot of what drives it, is not really, is not always what you want to do. And depending on your use case, you may think of prostate in human as being the same thing as prostate in a mouse or not, because it turns out that the mouse has 5 prostates. And most humans only have one, thank God. So is it the same thing or is it different? From a tissue perspective, it might be the same thing. From a functional perspective, it might be the same thing. From an anatomical perspective, it is different. From a morphological perspective, it's different. And of course, different organs that have different names might serve the same function. And if you're interested mostly in function, you may want to use Uberon to relate that. So I think that's pretty much it. Think of reusing. I know you are already. And it's hard to build an ontology, as most of you have figured out at this point already. So reuse whenever you can. Leverage existing cross-references to other ontologies so as to facilitate integration. And ontology development is always a partnership between ontologists who know little about domain knowledge, but know about organizing things and basic distinctions and have to make rookie mistakes, and experts, domain experts who know all about the domain, but sometimes have no clue about organizing things. So I need to end with my ontology joke. So what's the difference between an ontology and a car?
He
Anyone?
asked that last night.
Yeah. So I teased you last night with that. So you wouldn't think of building a car, would you?
Okay.
Think about it.
Okay. All right. Thank you so much.
Thank you.
Great input to the discussion. So we have time for quick questions. There's one from Bernard here.
So what would your advice to HubMap be in terms of term requests and term request pipelines?
Okay, so that's a very good, that's a very important question. So Stan Huff, who's developed many ontologies and who's done great thing in biomedical informatics he's at Intermountain Healthcare in Utah. Always says his ontology joke is take every ontology. There's always 10% missing, so it's never complete, and there's always something that you want to add to it. So one of the selection criteria might also be: is there a point of contact, and is there somebody who can help me extend the ontology? And it's the case for a bunch of them. It's the case, including for SNOMED, for example, which is something that most people don't understand and think that it's a fixed thing, and if you don't find what you need in it, you're out of luck. So there's ways of getting these things in. Something I haven't said also is that not all ontologies are static in the sense are pre-coordinated as we define them. So a pre-coordinated concept or term is something for which you have both a code and a term in the ontology. In SNOMED, for example, and in others as well, especially the ones built with description logics, when there's a model, a grammar, if you will, that's provided to you, you can create your own term. So if there's if kidney exists, that the left kidney doesn't exist, it's important for you to represent literality. Well, there's something in SNOMED that allows you to build left kidney with the conjunction, not just the mere conjunction, but with a grammar that associates a literality value and an existing concept, and you can extend it if you wish. It's likely that you will need to extend with the grammar or without grammar, that you will need to extend and create local codes to your ontology. That's what ends up being the case most of the time.
I mean, I'm going to add that, I mean, I have, in all of the playing around over many years, I found things that I, submitted to SNOMED, they make changes. It's an ongoing updating process. And so I think that you're going to have to, as I'm sure you've done a lot, is annotate things that you can't find and then push them to get them put in. I think one of the values in HubMap that I see is that these other ontologies, like Go in particular, may get more submissions for other things to add to it as a pathway forward to create stability, and SNOMED as well, so that all this other stuff that we're interested in is represented.
But that's the same thing in the gene ontology. That's the same thing. Most of the groups are responsive.
Yeah. But let's suppose that HubMap makes a choice of UMLS.
Mm-hmm.
And there's a term that's needed, and it's an atomic term, but it's not amenable to post coordination.
Yeah.
Okay? Where do we go?
Yeah,
do we go to
yeah.
SMA? Do we go to SNOMED?
Well, so you don't go to UMLS. You don't go to UMLS because UMLS does terminology integration. So we don't take we take terminology. We don't take terms. But you go to any of these groups, and some will be more responsive than others, in particular depending on the level of funding that they enjoy. And some have procedures for this, an infrastructure that allows you to submit terms. SNOMED has a request system for this, and the OBO ontologies, most of the OBO ontologies have their own entry points also for this. Yes.
It's interesting. As an integrator, you have an opportunity to also be a clearinghouse. And if you clicked on, if you were in, say, this integrated ontology and say, oh, I need this or I need SB here, you as an integrator would already know where it came from and could help to be a redirect to that source rather than the user saying, oh, this is an ontology, this is the anatomic term, so I better go figure out where this thing came from and then kind of manually forge that path. And there might be an opportunity to actually say if you're already integrating, you could also be a clearinghouse for that.
It's also a major commitment.
Yeah.
Yeah.
Because it puts a lot of work in the end user to figure out, oh, I have no idea where this came from, and I have to figure out, oh, this actually came from this ontology, that ontology. It's actually a lot of work.
And part of the case that I part of the case that I was making is that if you take the sum, you just getting on the graph is 90% of the problem, because you can navigate the graphs in various ways. So if you take that sort of, you don't want to take everything. There's hundreds of some vocabularies in there. You may not put them all in as I've done by literally integrating everything in UMLS, but it also gives you a very clear framework that if you do need to add some things to get something going in this meantime, there's a framework that you're adding to that works for 100 terminology, 100 vocabularies. So, where you really do have to manipulate and add in, you can do that in a way that will be easier for multiple to add and easier for NLM to integrate into the ones you've added it to as well. So the notion of creating new concepts, I think, is a thing that will happen in HubMap, not just new codes and new terms. I think there are new concepts that we're going to be bumping up against. And so I think thinking about how those concepts are submitted and managed among multiple places and communicated turns out to be really important to accelerate the process. There's a tremendous amount of infrastructure in these individual vocabulary managers that are then integrated. And if you understand that pipeline, I think you can be really smart about the things that you add and who you ask them.
It's an interesting point, even on the other hand, reconciling these different things together and say, you harmonize and say, oh, it's 4 out of 5, or why don't we automatically submit?
Well, I think you'd be surprised that overlap has been happening for a long time. It's surprisingly aligned.
Okay.
I mean, in my experience playing with this, Olivia and the team there lives this, but you don't find that anatomic term is a different concept in these different vocabulary. When it is the same one, UMLS has integrated them and made that concept that same anatomic term in FMA, and that has relationship to some code thing. They're related.
Most of the time.
Most of the time.
Yeah.
And there's 10% missing, right?
Yeah.
So, but I think the point is that is the goal, because all you have to do is get on the graph and you can get to where you're going. So that I just had a minute to show that representation, but the amount of that concept-based synonymy is just unbelievably huge. That's why I focused on it. And I think keeping that very much in mind is where the power comes from, because then HubMap is not going to be able to control what others do elsewhere. But if they're in some terminology, it's reasonably likely they can get to UMLS and they can get to where you are. You have to get on the big graph.